Welcome to the program. Today we're going to be covering lesson 1.5, casting and ranges of variables. This is going to close up unit 1 for us, so make sure that you are familiar with your learning objective and the topics, and let's get started. Our first topic will be covering the cast operator, our learning objective, evaluate arithmetic expressions that use casting. Take a look at these three actors and try to cast them in a role that they have portrayed in a movie. Let's start here with Robert Downey Jr. The role that I would cast him in would be Iron Man. So you can see I have Iron Man in parentheses in front of Robert Downey Jr. I'm going to use that as kind of like a verb. I want to Iron Man up Robert Downey Jr. And when we do, we get this. Next, let's move on to Jennifer Lawrence. I think I'm going to cast her as Katniss, so I'm going to Katniss up Jennifer Lawrence, and then you would get this. Finally, we have Michael B. Jordan. I'm going to Adonis up Michael B. Jordan, and this is what we get. So by casting, we turn one thing into another thing. We were turning an actor into a character. We can also cast in Java. When we cast in Java, we're going to turn one data type into another data type. So we have two operators. These are not new statements. These are just operators, just like we have our arithmetic operators for doing math, just like we have our assignment operator for taking a value and storing it into a variable. We now have our cast operators. Our cast operators are going to be responsible for turning one data type into another. So our first cast operator that we are going to see is the int cast operator. Notice your operators need to be surrounded in parentheses. The int cast operator turns whatever following value into an integer. And to do that, it's going to remove or truncate any decimal places. So we see a couple of expressions. We have int 3.2. So when we see that cast operator, you kind of read it like a verb. We're going to int up 3.2. And when we do, we're going to truncate or remove that decimal, and then that will evaluate to the int of 3. The next expression that we see is the int of 3.8. So when we cast 3.8 as an integer, truncate that decimal, that is also just going to evaluate to a 3. Our next operator is the double operator. It's going to turn any following value into a decimal number, meaning that it's going to add a 0.0 to the end of that integer. So if we double up a 3, use that double operator, that double cast operator with the parentheses and then the integer literal 3, that's going to turn that into 3.0, which we said before is a different value in Java. It is a value of the data type of double. Our next example, if we double up negative 12, we get negative 12.0. This aligns with our essential knowledge. The casting operators int and double can be used to create a temporary value converted to a different data type. It's a temporary value because we need to then store that into a variable or pass it as an argument into a method, or it just goes away. Casting a double value to an int causes the digits to the right of the decimal point to be truncated. This is known as explicit casting because we are explicitly telling the computer to cast that number to a different type by using that cast operator. Oh, you want to know when this happens in a statement? So what, you want like a precedence table? Yeah, we can look at precedence and see when that happens. So here is our full precedence table for Unit 1 with all of the operators that we have learned so far. So we can see that cast comes in there somewhere around the middle. It's a little bit higher than the middle. Parentheses still get evaluated first. Then we have our increment decrement operators. Then cast goes in there. Then we do our multiplicative, our times divide modulo. Next, our additive, our addition and subtraction. And then we have finally at the lowest level, level 1, we have our assignment operator and our compound assignment operators. So in math, we have PEMDAS, please excuse my dear Aunt Sally. In Java, we have some different operators. So we have PID CMDMAS. Please immediately, diligently congratulate my delightfully magnificent Aunt Sally. It stands for parentheses, our increment decrement operators, our cast operator, our multiplication division modulo, and then our addition and subtraction. We get to try to practice some precedence with our cast operator. So take a minute and try to work through these expressions, try to evaluate these expressions, and let's see what you get when you do. Our first expression, we are going to int 3.14. When we turn that into an int, that turns into the integer literal 3. Next line, we're going to double up a 3. When we double up an integer literal 3, we get the double value of 3.0. Next one, we are inting up D1 plus D2. This is where some precedence is going to come into play. We have a cast and an addition. The cast has a higher precedence at level 13 than the addition at level 11. So evaluating D1 and D2, we are int casting 3.7 plus 4.8. The int happens first, so that 3.7 turns to a 3. So then we're left with 3 plus 4.8, which is 7.8. Our next expression, we are using our int cast operator on the quantity D1 plus D2. Looking at our precedence table, the parentheses happens first. We are going to int up the quantity 3.7 plus 4.8. That addition happens first because it's inside parentheses. We're left with an integer cast of 8.5, and that's going to evaluate to an 8. Our next expression, we are casting D1 as an int, and then we are adding an int cast to D2. So we have 3 operators, an int cast operator, an addition operator, and an int cast operator. Those ints are going to happen first, the addition is going to happen last. So we're going to cast 3.7 as an int, that'll be a 3. And we're going to cast 4.8 as an int, that'll be a 4. 3 plus 4 is 7. Next, we have a double cast operator and the quantity I1 divided by I2 inside parentheses. We handle those parentheses first. So I1 is a 5, I2 is a 2. 5 divided by 2, according to Java, that is integer division. We have an integer literal 5 divided by an integer literal 2. That's going to give us our answer as an integer. That's going to evaluate to a 2. Then that double cast operator will turn that 2 into a 2.0. Our final one, we have a double cast operator and our division operator. The double cast operator happens first. So we have I1 divided by I2. So that's 5 divided by 2. The double cast applies first to that 5, turns it into a 5.0. We have a 5.0 divided by 2. And now we have a double divided by an integer. We no longer have integer division. We now get our answer as a double 2.5. Make sure you feel comfortable evaluating all of those expressions before you move on to the next topic. Our next topic is implicit casting. We talked about explicit casting earlier. Now we're going to talk about implicit casting. Our learning objective, evaluate arithmetic expressions that use casting. So your friend is moving and they ask you to help them move. And they give you a box that can hold only 3 items. You can't fit more than 3 items in there. And you go to help them pack, and they have 4 items left to pack. They have their clothes, they have their gaming system, they have their stuffed animals, and they have their computer system. Which of these 3 things do you pack, and which one do you leave behind? And is it fair for your friend to ask you to make this decision for them? Now let's imagine your friend asks you to help them move. They give you one giant box that can hold 10 items. And when you go to pack, you notice that there are only 4 items in the room to pack. What do you pack and what do you leave behind? Well, in this case, you don't need to leave anything behind. You can throw it all in the box and you would still have plenty of room for other items. Java runs into a similar situation when you are asking it to cast between an integer and a double. On the left, we have a container holding an int. On the right, we have an empty container that can hold a double. you'll notice the container for the double is twice as big as the container for the int because in memory, a double is 8 bytes where an int is only 4 bytes. If that container for that int is full, with whatever that green liquid is, it looks like ecto cooler to me. If we want to take that int and put it into a double, it would work just fine. There would be plenty of room left over. So Java will convert from an int to a double for you without asking because it doesn't have to worry about losing any data. It doesn't have to worry about losing any information. There's plenty of room to take the information from an int and put it into a double. On the opposite side, if you start with a container the size of a double and you try to pour that data into a container the size of an int, some of that data will pour over and spill, and you will lose that data. That data that you are losing will be those decimal places from that doubled number. So Java will not convert from double to int for you unless you specifically ask it to. You see some code samples on the left. In both samples, we are declaring and initializing two variables. We are declaring a variable of type int and naming it whole number and assigning the value of 5 to it. And we are also declaring a variable of type double and naming it decimal and assigning the value of 3.14 to it. In the example on the top left on line 4, you can see that we are trying to take that integer variable whole number and we are trying to assign it to the double variable named decimal. So we are trying to take that whole number, which stores a 5, and put it into a spot big enough for a double. Java has no problem doing this. There's plenty of room in that double variable to hold an int value. So Java will implicitly convert from int to double for you without you asking. So that 5 will get turned into a 5.0 and stored as a double. In the example on the bottom left on line 4, you can see we are trying to take that double variable named decimal and we are trying to assign it to the variable named whole number, which is an int. We are trying to take a double and store it into an int. We know an int is not big enough. It doesn't have space for decimal places in it. So Java will not convert from double to int for you unless you explicitly ask it to by using an int cast operator. If you tried to run that code on the bottom left, you would get an error. It would tell you incompatible types, possible lossy conversion from double to int, meaning that you can lose some data. You're going to lose those decimal places. We're going to see how to do some rounding in Java. Our learning objective, evaluate arithmetic expressions that use casting. Think of some things that are easy to do, but hard to teach. Some things that might be easy for you to do, but are actually quite difficult to teach: tying your shoes, throwing a ball, and rounding. For a machine, these are easy to do. We can have a machine that ties our shoes for us. We can have a machine that throws a ball for us, and we can have a machine round for us. And this is what we're going to figure out how to do. How do we teach a computer to round for us? Well, we need to understand how rounding works. So we're going to check the bounds of a number. So we're going to work with values from 3.0 all the way up to 3.99. And anything from 3.0 to 3.49 should round down to a 3. Anything from 3.5 to 3.99 should round up to a 4. So now that we know how that works, we can start to develop an algorithm to have the computer do this for us with any number. So rounding in Java is a two-step process. Step 1, you're going to add 0.5 to your number, and we're going to see why. We saw those bounds on the previous page, so we are testing those 4 bounds. We have our 3.0 all the way up to our 3.49. That needs to stay as a 3 at the beginning. And then we have our next set of bounds, which is 3.5 to 3.99. We want those to round up to a 4. The first two I highlighted the first number in green because we want that to stay a 3. The second two, I highlighted those numbers in red because we want those to turn up to a 4. And so if we add 0.5 to these numbers, 3 plus 0.5 is 3.5. If we only look at that first number, it's still a 3. That's what we want it to stay. 3.49, we add 0.5 to it, that goes up to 3.99. That first number stays at 3, which is what we want. Looking at our next set of bounds, 3.5 plus 0.5, that first number turns into a 4, which is good because we did want that to round up to a 4. And our last one, 3.99 plus 0.5 is equal to 4.45. That first value is still a 4. So all of our first values, all of our whole number values, all of our integer values are correct. We just have all these decimals at the end, which are no longer correct for rounding. We don't want these decimals anymore. Well, luckily, we know a way to get rid of decimals. And that's where step 2 comes in. We're going to cast our number to an int. So that 3.5 that we got for an answer, if we cast that to an int, we're just left with the 3 that we want. We got rid of that decimal that was incorrect. Our second example, that 3.99, if we cast that as an int, we just get our 3, which is the number that we want. Our next one was a 4.0, which was technically correct, but we're going to follow these 2 steps on every single number without checking to see if they're correct. So if we cast that 4.0 as an int, we get our 4, which is our rounded number. And finally, our 4.45, cast that as an int, we have our 4. So it's 2 steps. You need to add 0.5 to it, and then you need to cast it as an int. Now, if we remember our precedence, ints will always try to happen first in an arithmetic expression. So we need to make sure that we prioritize this addition to happen first. We need this addition to happen before we cast it. So we have that cast in a code example. We start our block of code by declaring and initializing 2 variables of type double. So those are going to go in our stack memory. We have num1, which is going to be the value 3.14. And then we have num2, which is going to be the value of 3.75. We're going to round one of those numbers on line 4. Remember, it is 2 steps to round. We need to add that 0.5 and we need to cast as an integer. Now, to do that all in one arithmetic expression, we need to make sure that addition happens first. So we put the addition in parentheses to make sure, according to precedence, that addition happens first. So when we evaluate that right side, we have num1 plus 0.5. That evaluates to 3.64. We still had our cast operator to handle next. So when we int 3.64, that turns into a 3. And we're going to take that 3 and put it into num1. Now, num1 is a double, so when we put that value in there, Java will implicitly cast that as a 3.0. We're trying to put an integer into a double, and Java will implicitly cast that back up. Our next example is on line 6. Again, we have our parentheses. In order to move that up in our precedence table, we have num2 plus 0.5. That's going to be 4.25. We're going to cast that as an int. And so that becomes a 4. And that goes back into num2. We're trying to put the integer value of 4 into a double variable. Java's going to cast that 4 to a 4.0. So we can see from our 2 examples, the 3.14 correctly rounded down to a 3, the 3.75 correctly rounded up to a 4. That lines up with our essential knowledge that values of type double can be rounded to the nearest integer by casting as an int the value of x plus 0.5 or casting as an int the quantity x minus 0.5 for negative numbers. Speaking of negative numbers, we're going to look at an example that features some negative numbers because we have to work a little bit different with negatives. So looking at our values, we have a negative 3.14. If we look at a number line, remember our negative numbers are going to be to the left of 0. And so if we have a 3.14, that actually needs to round up to a negative 3. And a 3.75 needs to round down to a negative 4. So it's the opposite because our numbers look like they're going the opposite direction than we're used to. Positive numbers, we have our 1, 2, 3, 4. Positive 3.14 rounds down, where negative 3.14 rounds up. So instead of adding 0.5, we're going to have to subtract 0.5 from our numbers. So let's go ahead and see what this looks like. We're just going to put our variables in memory. We have num1, which is our negative 3.14 this time, and our num2, which is our negative 3.75. Looking at our first example, parentheses, we have num1, which is negative 3.14 minus 0.5. So a negative minus a negative, that's going to be negative 3.64. And then we're going to cast that as an int. We're going to get our negative 3. Now we're going to try to take that negative 3 and put it back into num1. Java is going to turn that into negative 3.0. Our next example, we have num2 minus 0.5. Num2 is negative 3.75 minus 0.5. That's going to be negative 4.25. We're going to cast that as an int. That's going to be negative 4. We're going to put that back into num2. Java is going to turn that into negative 4.0. So the thing to remember is if you are rounding a positive number, you add 0.5. If you are rounding a negative number, you need to subtract 0.5. Our last topic, not only for this lesson, but for this unit, is range of variables. Our learning objective, evaluate arithmetic expressions that use casting. So here we have an odometer that's going to flip numbers and count. So what number would come next as this odometer counts? It would be 9,998. Then the number that comes next, 9,999. And then what number comes next? The number that should come next is 10,000, but we don't have room to make a 10,000. So all of these nines would flip back to a 0. We would need to put a 1 in the next column, but we don't have the next column. So we just started back over at 0 again. So what is the biggest number that you can store in an integer variable in Java? Yep, I did mention that in lesson 1.2. It was, 2 billion something. 2 billion what? You don't need to remember what the biggest number that Java can store in an integer value because Java remembers what is the biggest number it can store in an integer value. You can just ask Java, and Java will tell you that it's precisely 2,147,483,647. We just need to know the right way to ask Java what that number is. And we do that by saying integer dot max value. Now we should be somewhat comfortable with this statement. That integer part on the front, that integer dot, we should recognize that as a class or just a collection of things. We've seen different classes before. We've seen the system class, we've seen system dot, we've seen the math class, we've seen math dot. Now we're seeing integer dot. On the right, though, we're not seeing a method. We don't have the parentheses at the end in which we can pass in parameters, and it's all in capital letters. That's telling me that it is a variable and it is actually a final variable, meaning that it cannot change values. So max value is a variable that belongs to that integer class. And the whole job of that variable is just to hold this really big number so that we can ask Java, what is the biggest number an integer can have? We can also ask it what the smallest value is. It also knows integer.min value, and it will tell us that is negative 2,147,483,648. So these are two class variables. The class that they belong to is integer. The variables, and they are final variables, meaning that they cannot change value. We have min underscore value and max underscore value. So max value holds the largest integer that an int can hold, and min value holds the smallest integer value that an int can hold. And they're really just there just so we can reference them, so we can ask Java, so we can get those values. So we know the biggest and smallest numbers that we can put into an int. It's 2 billion something and negative 2 billion something. So what if we try to put a number bigger than that into an int? What if we try to put 3 billion into an integer variable that we are naming num? What is going to happen? Well, Java will not let us do that. It will not let us put a number too big into that integer. In fact, we will get an error. It'll say integer number too large. So let's start off by putting in the biggest number that an integer can hold. Java is fine with that. It fits in that variable perfectly. If we try to print it out, it would tell us that number. Now that we put the biggest number in there, what's going to happen when we try to add 1 to it by using our increment operator of num++? So thinking about that one, what actually happens is it doesn't give us an error. It just rolls back over to the smallest number, which is the negative 2 billion number. So we were at the top and we tried to add one more and there was no space. So it rolled back over to the smallest number, kind of like that odometer that we saw at the beginning. This is known as integer overflow when an arithmetic operation attempts to create a numeric value that is outside the range of the data type. So if we're at the top and we try to add any sort of amount, 1, 2, 3, it'll wrap back down to the bottom. If we're at the bottom and we try to subtract any amount, it will wrap back up to the top. This aligns with some of our longest essential knowledge. Integer values in Java are represented by values of type int, which are stored using a finite amount of memory. Therefore, an int value must be in the range from integer min value to integer max value inclusively. If an expression would evaluate to an int value outside the allowed range, an integer overflow occurs. This could result in an incorrect value within the allowed range. So you're going to stay within that allowed range. It will wrap from the top to the bottom or the bottom to the top, but you might not have the value that you think you would have. You thought you would have a number that was bigger than that 2 billion number, when really now you're in the negative 2 billions. You can think of this like Pac-Man, those tunnels on the side. When you go out the tunnel on the right, you come back in the tunnel on the left. If you go out the tunnel on the left, you come back in the tunnel on the right. That's kind of what integer overflow is. That's going to bring us to the end of this lesson and the end of Unit 1. Review how you feel about our learning objective. Read over those recap statements. Make sure that you hit me up with any questions or concerns that you have regarding this lesson. Join us in our next unit and keep programming.